Hello, welcome to this week's Center of Math's problem of the week. For this problem, we want to find an n-digit number that has only odd digits and is divisible by 5 to the n. We're going to do this by constructing a number, and it's going to look like this thing here. Here, aj is equal to 0 or 1, and we're going to decide whether or not it's 0 or 1 by trying to make this whole thing have only odd digits. One thing we should know about this, this sum is it's at most 2 to the n minus 1, and 2 to the n times 5 to the n gives us 10 to the n, which is an n plus 1 digit number, the smallest n plus 1 digit number we can have. So this thing has to be less than n digits. And now, note that to the j times 5 to the n gives us 5 to the n minus j times 10 to the j. And this is the form. We have some numbers here, 5, and then followed by 10 j zeros. So here, we're going to set a0 equal to 1. So we have at least 1 5 to the n. Now 5 to the n. 5 to the n starts with 5, and then there are some numbers. Now a1, 2 to the 1 times a to the 1 times 5 to the n, it gives us something in the form So now we have a 0 here, a 5, and then some numbers. Now we're going to decide whether or not a1 is going to be 1 or 0, depending on whether or not, these are different than these numbers. So let's call these C. So we're going to decide whether or not a1 is going to be 0 or 1, depending on whether or not c1 is odd or even. If it's even, we set a1 equal to 1, then we're going to, because this is a sum, we add these two. c1 plus 5 would give an odd number. If it's odd, we set a1 to 0. This is just 0, c1 stays odd. So in this way, we force the second digit to become odd. And we proceed like this for arbitrary j. And by doing this, we force each of these c1, c2, dot, 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 all the integers to become odd. And this, by doing this, we're bound to also get an n-digit number, because if we don't have an n-digit number, the final j for the final number, we're going to have something of the form 5 and then n minus 1 zeros. This is an n-digit number. And if we don't have an n-digit number, then the c for the nth digit is going to be 0. 0 is an even number, so we're going to set, in this case, an minus 1. We would set to 1, and then we would get our n-digit number. And as an example of this, we can do this to, say, 5 to the 3. So 5 to 3 is 125. 2 times that is 250. 2 times that, again, is 500. We can see we have a 5 here. We have a 5 here, followed by 0. Then a 5 here, followed by 2 zeros. And then we'll proceed as described. Here, we're going to have 1, 5, 3. Now 2 is even, so we want one of these. We're going to have 1, 2 times 5 to the 3. And then 2 plus 1 is 3, which is odd. So we're going to have 0 times 2 to the 2 times 5 to the 3. And adding these two up, the 3. So we see 3 times 5 to the 3 is a 3-digit number with only odd digits, 375. And yeah, we can do this construction for an arbitrary number of digits, so we know we can always find such a number in this way. And that solves the problem. Thanks for watching. Please check out centerofmath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.